So this is the question in page 24 on mixed exercise, right? The equation x squared minus 2tx plus t equals 0, where t is a positive constant, has roots alpha and beta. Now in part A, it asks us to find alpha, beta, and alpha squared, beta squared in addition. We're going to find this in terms of t. So alpha times beta is c over a, where c is t and a is 1. So it's going to be t. Let me write these here because I will be using them. So alpha times beta is t. Right. For alpha squared plus beta squared, I will be using this. Alpha plus beta squared is alpha plus beta times alpha plus beta, right? So this is alpha squared and alpha times beta, and then I have another beta times alpha here, so there will be two of them, 2 alpha beta, and I have beta times beta, which is beta squared. So now if I take 2 alpha beta to this side, I'm going to have alpha plus beta in brackets squared minus 2 alpha beta being, say, alpha squared plus beta squared, right? So if I just swap everything, I will be able to find alpha squared plus beta squared. So let me clean up here and rewrite it. Now it's gonna be alpha squared plus beta squared. That's gonna be alpha plus beta bracket squared minus 2 times alpha times beta. So this is well, we have to calculate that. Let's do it here. Alpha plus beta is minus b, so it's minus 2t over a, which is 1. So this is basically 2t over 1, which is 2t, right? So I have to write down 2t here. So instead of alpha plus beta, I have to write down 2t. Let me write here that one. Alpha plus beta is 2t. And then for here, I will be writing 2t squared minus 2 times, well, alpha beta is t, so I'll substitute that. What I'm going to have will be 2 squared is 4t squared is t squared minus 2 times t, 2t. So that is the expression for alpha squared plus beta squared. So this is the answer to part A. In part B, it is given that alpha minus beta is 24. Find the value of t. Alright. Now, let's write down this value as well, because I have to rub all this. Alpha squared plus beta squared is 4t squared minus 2t. So let's rub this. Now, let's start with part B. Alpha minus beta squared is equal to alpha minus beta times alpha minus beta. Now, it's alpha times alpha, alpha times beta, beta times alpha, beta times beta. Let me write these down. It's alpha squared minus alpha beta minus alpha beta plus beta squared. So if I clear this up, it's going to be alpha squared minus 2 times alpha beta plus beta squared. And if I just take minus 2 beta squared to the other side, I'm going to have alpha minus beta squared plus 2 alpha beta, which is alpha squared plus beta squared. Now why am I doing that? Because, well, I know this, which is given to be 24. I know alpha beta, which is t, and I know alpha squared plus beta squared, which is 4t squared minus 2t. So if I write everything here in terms of t and numbers, I will have the following. Right, if I go on with this, that's going to be 576, 24 squared, that is, and it's plus 2t equals 4t squared minus 2t. Well, if I have everything on the right hand side and then swap sides, I'm going to have 4t squared minus 2t minus 2t minus 576, which will be equal to 0. If I simplify, I have 4t squared minus 4t minus 576 being 0. If I take 4 out, it's going to be t squared minus t minus 144. And then if I divide everywhere by 4, I'm going to have this equation, t squared minus t minus 144, which is 0. To find the value of t, we have to solve this equation. So let's once more clean this place up. Please don't do this in the exam. And then let's write down the equation here, or basically I can just catch it. Well, I won't. I'm going to write down again. T squared minus t minus 144 equals 0. Now 144 is a perfect square number, so I can't find anything that adds up to minus 1 and multiplies out to 144. Hence I have to go with the discriminant, the quadratic formula. So it's going to be A being 1, B being minus 1, and C being minus 144. It's going to be, I will only calculate the positive value, by the way, because t is positive. So it's going to be minus negative 1 plus, I'm not going to go with minus because it's a positive value, minus b squared being, let's write again, minus 1 squared minus 4 times a is 1, c is minus 144, in square root divided by 2 times a, which is 2 times 1. So if I simplify this, I end up with 1 plus square root of 1 plus 576 over 2. Basically it is 1 plus square root of 577 over 2. This will give me 12.5 up to 3 significant figures. Now if I use this, then I find first of all part B. If I use this for part C, I think I can find an equation with the following given roots. Let's write the value again here. So this part is our findings part. I'm going to write t equals 12.5. Now let's rub all these again. Okay, in part C I will try writing these roots, the sum and product of these new roots, and try to find out the new a, b and c, the coefficients of the new equation. But before, let me calculate alpha beta. Now we said that is a t, so basically that's 12.5. Right. For alpha plus beta, we found out that it's 2t, so it's 2 times 12.5, which would be 25. And in case I need it, let me calculate that. Alpha squared plus beta squared is 4t squared minus 2t. So let's do this calculation. That's going to be 4 times 156.25 minus 25, which will give me 625 minus 25, so it's going to be 600. So let me write these values here. That is, well, 12.5. This is 25, and alpha squared plus beta squared is 600. Right, now let me rub these again and try to solve C. So I have to play with those expressions a little bit. It's alpha over beta. Now I have to calculate the sum first. To do that, I have to equate the denominators. So that's gonna be alpha squared plus beta squared over alpha beta. So basically it's gonna be 600 over alpha beta is 12.5, which would be 48, right? This is where I would introduce minus b over a. Let's keep it like this for now. And when it comes to alpha over beta times beta over alpha, I'm going to end up with alpha beta over alpha beta. Regardless of those values, I'm going to end up with 1. And this would be, say, c over a. Now, considering a being 1, I can write down the equation, the new one. Let me try here. The new equation to be like x squared, right, plus bx plus c equals 0. Now, if 48 is minus b over a, or basically minus b, I'm going to end up with x squared minus 48x, and then if a is 1, then c is supposed to be 1, so I'm going to say plus 1 equals 0. So basically, this equation is the one that is asked in part C, where the roots will be the comparison of alpha and beta here. So basically this is how we are supposed to solve this question. It took me around 30 minutes to explain this, and that's why I was writing slow, but well, it should take around 5 to 6 minutes to solve this if you're confident with these work. But again, I mean, the idea is simple. I always go find the sum alpha plus beta and the product alpha beta, right? And then I'm trying to express whatever is asked to me in terms of alpha plus beta or alpha times beta, right? That's all about playing with these expressions. And it's very important that you know that alpha plus beta squared is alpha squared plus 2 alpha beta plus beta squared, and alpha minus beta squared in brackets would be alpha squared minus 2 alpha beta plus beta squared. Well, if you don't remember these expressions, you can always expand these to find them out. But what you have to focus is that you can always take these to the other side, right? And then you can leave alpha squared plus beta squared alone to find that expression. I hope this helps. Thank you.